Hello dear friends, today we are going to discuss about the chemical bond. Especially this topic I will relate with the concise inorganic chemistry book which is written by J.D. Lee, and this book will be very important for the student which are specially doing the preparations of IIT JE or NEET, or the students which have passed and they're doing BSc or MSc. This book is very important. It's the basic concepts of chemical bonding. So let's start our chapter chemical bonding. Now the question is about that why there is a stable configuration, why there is an attainment of a stable configuration. First of all, I would like to tell you about that each and every atoms combined with another atom to form a molecule which is formed by the bond, right? Each and every element has a tendency to form a bond because that elements either can donate an electron or accept an electron, or they can share an electron. So they are having a tendency to attainment of a stable configuration. So as I have already informed you that how to understand the concept of electronic structure and how we will consider that zero group elements. Each and everything is related to this topic. First of all, I would like to tell you about that the nature loves stability. Similarly, each and every elements like to get a stable configuration, that is inert gas configuration, and for that the elements has to either accept the electrons or lose the electrons or to share the electrons. So let's start about the types of chemical bonding. So you can see here the types of bonds. Atom may attain a stable electronic configuration in the three different ways: by losing the electrons, by gaining the electrons, or by sharing the electrons. So elements may be divided into electropositive elements whose atom gives up one or more than one electrons. So you can say here that they are electropositive elements because they lose their electrons very readily. Similarly, electronegative elements which accept the electrons, and elements which have little tendency to lose or gain electrons. So there are the three types of bond. As you can see here, the three different types of bond may be formed depending on the electropositive or electronegative character of the atoms involved. So I am showing you that how these three types of bond are being formed. As you can see that electropositive element plus electronegative elements give a formation of ionic bond. Electronegative element plus electronegative element give a formation of covalent bond. Electropositive element and electropositive element give a formation of metallic bond. So the ionic bonding involves the complete transfer of one or more electrons from one atom to another. Covalent bonding involves the sharing of a pair of electrons between the two atoms, and in a metallic bonding the valency electrons are free to move throughout the whole crystals. What I mean to say is that whenever you talk about the ionic bond, then ionic bond there is a complete transfer, not the sharing. It is a complete transfer of one or more electrons. So let me show you that how they are doing the complete transfer. So as you can see here, that introduction to chemical bonding in the two-dimensional Lewis structure. Here you can see that how the Lewis dot structure chemical bond is formed. So first of all, you must understand about bond. As already I have told you, each and everything in the nature loves stability, right? And elements, how they are holding together, the force that hold the atoms together is called a bond. Now you can see these two atoms which are present here. Covalent bond is formed by the sharing of electrons between the two atoms, and if I talk about the ionic bond, then there is a complete transfer of electron from one atom to another atom. Then there is a formation of ionic bond. So you can see here that how this ionic bond is formed. If I talk about the lithium fluoride is an ionic compound. So how this lithium one electron, means last cell electron, will transfer to the fluorine atom. So lithium will become cation and fluorine will become anion, and there will be a bond formation between the lithium and fluoride, and this compound will be known as ionic compound. So here ionic bonds are more stable, as you have seen, because there is this electrostatic force between them, so they are more stable. If I talk about the magnesium chloride, so here you know very well there are two valence electrons between the magnesium atom. So these both the valence electrons are being transferred to each and all chlorine. Here you can see the 2 chlorine atoms are there, so there will be a formation of MgCl2. Each chlorine will accept 1 electron from the magnesium, and there will be a formation of MgCl2. Similarly, like lithium fluoride, magnesium chloride, these both are ionic compounds, and ionic compounds are more stable, as I have already told you that how do these molecules are becoming the most stable. So this was the formation of ionic compound. Yes, you have seen. If I talk about the nature, you know very well, in the nature there are 118 elements. All these elements, as you can see, in this elements, the zero group elements means inert gas elements. If I talk about, that's called noble elements also. In this noble elements can exist freely in the atomic form, means they are well stable, they do not require any types of reaction, so they can exist in the stable form. But if I talk about the lithium fluoride, so you can see lithium is also here accepting the helium configuration, and fluorine is accepting here the neon configuration. So you can see both the atoms attain the nearest inert gas configuration, right? Lithium has attained helium configuration and fluorine has attained neon configuration. So you can see here the lithium fluoride and ionic compound, the same electrons configuration as neon has attained to the fluorine and helium has attained to the lithium. So now this is the formation of a covalent compound. After understanding the concept of this ionic compound, you must have a knowledge about the electronegativity values. This is the most important thing in the periodic table, as you may have heard in your previous chapter also, that electronegativity values. So you know very well the lowest electronegative value is of francium and the maximum is of fluorine. So you can see here that how it reduces, means how it decreases from right to left in the periodic table, it decreases, and from top to bottom also it decreases, right? So the maximum is of fluorine, the atomic number of fluorine is 9, and the value of electronegativity value is 4. So now question is, if you talk about the bond formation, there must be a difference in the electronegativity value, that is delta En, as we have seen here, that if I talk about the ionic bond, then ionic bond must have the difference of electronegativity values between the two elements, it must be greater than 2.1. If I talk about the lithium fluoride, so you know very well the fluorine electronegativity value is 4, and lithium I talk about then 1. 4 minus 1, that is 3. So 3 is greater than 2.1, so that's why here there is the formation of ionic bond. Remember, dear students, that if there is electronegative values written, then you must remember that if the difference of electronegative values between the two atoms is greater than 2.1, then there will be a formation of ionic bond. But if I talk about the lithium oxide, then you know very well the electronegativity of oxygen 3.5, lithium 1, so 2.5. So 2.5 is greater than 2.1, so there will be a formation of ionic bond. You can see here lithium and oxygen. Oxygen is a central atom, right? So you can see here, because the electronegativity is higher than the lithium, so both the electrons will be attracted by the oxygen, and there will be a formation of Li2O, that is lithium oxide. Here the lithium will attain helium configuration and oxygen will attain neon configuration, so both the elements will become stable and there will be a formation of ionic compound, as we have seen. Now if I talk about the types of bond, so generally you must remember the electronegative value greater than 2.1 ionic bond, less than 2.1 covalent bond. You must have a knowledge about the electronegativity values. If I talk about the hydrogen bond, you know very well hydrogen electronegativity value is 2.1. So 2.1 minus 2.1, it is 0, right? 0. It is less than 2.1, so there will be a formation of covalent bond. You can see here hydrogen electronic configuration 1s1, another hydrogen electronic configuration 1s1. Both the electrons will share with each other, mutual sharing, and they will gain an electronic configuration of 1s2. So this 1s2 gives a stable configuration, that is a helium, that is a noble gas configuration. So here you can understand, since the electronegativity value is less than 2.1, the electronegative values difference is less than 2.1, then definitely there will be a sharing, means sharing of electrons, and it will be a formation of covalent bond. If you still have a doubt related that what is covalent bond and what is ionic bond, you must remember the difference values of electronegativity. Here you can see both the electrons are being mutually shared by each other, and there is a formation of covalent bond. So internuclear distance, as it increases, you know very well, from the left to right, if we go, then the atomic size decreases. But if I talk about the internuclear distances, then internuclear distances increases, because there are two atoms, and the two atoms internuclear distance between the hydrogen and hydrogen atom, as you can see here, if I am plotting a graph between the hydrogen atom, so this graph will give you the sure definitions of the covalent bond formation, as you have seen in this animated video. Now let's come to the topic of the textbook. So as you have seen that how this covalent and ionic bond are formed, but if I talk about the percentage ionic character, each and every ionic compound, if I talk about, then they also have some covalent character. Or if I talk about some covalent bond, they also have some metallic character. If I talk about metallic bond, they also have some covalent or ionic character. So there is a triangle of this metallic, covalent and ionic character. You have to just learn this table. According to this table, you will be 100% clearance of the concept that how this metallic bond, or the metallic covalent bond, or the metallic ionic bond, or covalent bond, or ionic bond, you can just see that how much percentage ionic character or covalent character or metallic character are present in this triangle. So transition between the main types of bonding. Few bonds are purely ionic, covalent or metallic. Most are intermediate between the three main types and shown some property of at least two. The ionic bonds are formed when the electropositive elements react with the electronegative elements. Consider that the ionic compound sodium chloride. A sodium atom has the electronic configuration of 1s2, 2s2, 2p6, 3s1. And the first and second cell of the electrons are full, but the third cell contains only one electron. When this atom reacts, it will do in such a way that it attains a stable electronic configuration. The noble gases that have a stable electronic arrangement, and the nearest noble gas to the sodium is neon, which has a configuration of 1s2, 2s2, 2p6. If the sodium atom can lose one electron from its outer cell, it will attain this configuration, and doing so the sodium acquires a net charge of +1, is called sodium plus. What is called? Sodium plus. Now the positive charge arises because the nucleus contains 11 proton with a positive charge, but there are now only 10 electrons. Sodium atoms tend to lose an electron in this way when they are supplied with the energy, and so sodium is an electropositive element. So you know very well, here you can see the sodium atom, that is equal to sodium plus electron. Chlorine atoms have the electronic configuration of 3p5, 1s2, 2s2, 2p6, 3s2, 3p5. They are only one electron short of the stable noble gas configuration of argon. Argon electronic configuration is 3p6, 1s2, 2s2, 2p6, 3s2, 3p6. And when the chlorine atoms react, they gain an electron. Thus chlorine is an electronegative element. So you can see here the chlorine atom plus electron gives you the chloride ion. Though the gaining of an electron, an electrically neutral chlorine atom becomes a chloride ion with a net charge of -1. So here, as you have seen the sodium chloride, how the bond is formed by the gaining and losing of electrons. Now if we talk about hydrogen fluoride, the difference of hydrogen fluoride electronegativity value is 4 minus 2.1, that is 1.9. So can you tell me which type of bond will be formation? You know very well it is less than 2.1, right? So there will be a formation of covalent bond. Here the hydrogen will share one electron with the fluorine, and fluorine will share its one electron with the hydrogen. So hydrogen will get its duet and the fluorine will get its octet, right? So here, after sharing the electrons, there will be a formation of covalent bond. As you can see here, the structure of delta negative and delta positive means that percentage ionic character, as I have already informed you about, there are some percentage of ionic character. right? So that's why here it is written delta plus and delta minus. So but it is a formation of covalent. But if anyone will ask you which type of bond is there, so remember this data or table. If the electronegativity value is greater than 2.1, ionic bond, 2.1 to 0.4 polar covalent bond, and less than 0.4 non-polar covalent bond. So in the covalent there are two types, polar and non-polar. 2.1 to 0.4, so there will be a polar covalent. Polar covalent will give you the shape just like hydrogen fluoride. As you can see, the higher electronegativity values, there you can see the polar covalent, and when there will be value less than, there will be a non-polar covalent. Now you can see here why do bonds form, how do bonds form, and types of chemical bonds. Non-polar covalent bond, now you can see the hydrogen both are having the same electronegativity value, so that is a non-polar covalent. And if I talk about hydrogen fluoride, since there is a difference of electronegativity value, so it is a polar covalent bond. Now talk about the ionic bond, the transfer of electron from lithium, one electron will go to fluorine, so there will be a formation of ionic bond. There is electrostatic force between these two atoms. Now chapter 2, introductions of Lewis structure, very very important for our this topic. Lewis structure indicates the gross connectivity of atoms. What is this Lewis structure, what do it indicates, and how do it connects to the atoms, how it makes the atom stable. As we know very well that each and every element has an affinity to complete its inert gas configuration, nearest inert gas configuration. Similarly, now you can see here the boron, carbon, nitrogen, oxygen, fluorine having the electronic configuration 2p1 to 2p5, the valence electron 3, 4, 5, 6, 7, and you can see the atomic diagram of Lewis diagram, because the valence electron as they have shown in the outermost orbital. Now take about the carbon, right? Carbon has the 4 valence electron in its outermost cell, and take lithium, beryllium, boron, carbon. Now if we are talking about the carbon, just suppose the carbon is having 4 valence electron. Now just take the atomic diagram of Lewis, so you will see that if any element is there and above both sides their valence electrons are represented, so that is known as Lewis symbol or Lewis dot symbol represented. Now you just see here each and every element has a tendency to complete its octet. Just suppose about the fluorine bond. Fluorine is having 7 valence electron in its outermost. Another fluorine is also having a 7 valence electron in its outermost cell. So 2s2 2p5, 2s2 2p5. Now both the fluorine will mutual sharing of 1 electron, and they will get the nearest inert gas configuration of neon. Both the fluorine will get 88 electrons, so there will be a formation of covalent bond. Yes, any halogen, if I talk about not only about the 2, I can tell you Cl2, Br2, I2, any of this halogen compound. Now rules for drawing the Lewis structure. You must remember how many valence electrons are there in their outermost orbit. Count the valence electron first of all. Second point, how many covalent bonds are formed between them. As you have seen, the monovalent, divalent, trivalent. Use the remaining electrons to yield full valency for all the atoms. Just suppose about the H2O. Here you know oxygen has 6 valence electron and both the hydrogen has 1 electrons. So total number of valence electrons will be 8 electrons. Total number of valence electron 8 electrons. Got it? Similarly, you must remember in this periodic table the group number shows you the valence electron, first group, second group, third, fourth, fifth, sixth, seventh, eighth. Right? So here you can remember that what are the valence electron of these different elements in the whole periodic table. Just suppose the H2O. Oxygen is having 6 valence electron, right? And 2 electrons it requires to get it inert gas configuration, right? So now question is how they will attain. So hydrogen will give 1 electron to the oxygen and another hydrogen will give 1 electron. So now you can see here the oxygen gains its inert gas configuration 8 electrons of neon. And now talk about the hydrogen. Hydrogen is also having 1 electron, and since the electrons are being shared by the oxygen, so they also have 2 electrons, so they will get helium gas configuration. Means helium is the inert gas, so helium configuration it will gain. So now oxygen and hydrogen both will be having a stable electronic configuration. Talk about the ammonia. How many valence electrons are there in ammonia? Nitrogen is the 15th group, since it has 5 valence electrons in its outermost orbit, and hydrogen, there are 1 valence electron, so there are 3 atoms of hydrogen, so 1 plus 1 plus 1, so 5 plus 3 is equal to 8 electrons. So you can see here each and every group elements. If I talk about the valence electron, so you must remember that each and every element has the valence electrons in its outermost cell. It depends upon the group number. So here NH3, you know very well, here each 3 bonding electrons will be bonded by the hydrogen. Hydrogen will get its duet complete and nitrogen will get its octet complete. So 5 valence electron was already there, and from each hydrogen atom 1 electrons was shared, and nitrogen have completed its octet, and all the hydrogen have taken 1 electron from the nitrogen and they have completed their duet. So now if I talk about the N2 bond, nitrogen. So nitrogen, you know very well, nitrogen has 5 valence electrons, 5 plus 5, 10 valence electrons. But if I talk about here, there is no 10 valence electron, it is 8 valence electron. How? Now talk about the 5 valence electron. But here the 3 means all the 3 means, if I talk about here nitrogen, if you will do the 5 valence electron and 5 valence electron, if you put a single bond, the 6 it will get. But if I take all the 3 bonding electrons, how many? 3 bonding electrons. If I take 2, then also you will see they are not getting octet, right? If you take about the 5 valence electrons are there, both the nitrogen atoms. Now the 2 electrons will be shared, so 7 electrons will be there. Now think about the 3 bonds between the nitrogen and nitrogen atom. Means 3 electrons of both the nitrogen atoms share their electrons and form an electron pair. So now you can see that these 3 bonds, now the valence electrons of the nitrogen will be total, each and every nitrogen will have 8 valence electrons. You can see here 2 plus 3 and the 3 electrons are been shared. Here also 2 plus 3 and the 3 electrons are been shared. So both the nitrogen atoms are having 8 electrons. That is the nearest inert gas configuration, that is of neon. Remember this formula. Now let's go ahead about the carbon dioxide Lewis dot structure. Just count the total valence electron. Carbon is having how many? 4 valence electron. Oxygen 6, 6 plus 6 plus 4, 12 plus 4, 16. Now just see the structure, how many bonds will be there between the carbon and oxygen. Just suppose here, if carbon is having 4 valence electrons and if they will share 1 electron, so what do you think? Both the oxygen will have 7 electrons or 8 electrons? 8 electrons now. And what's about the carbon? 2 carbon have 4 electrons. Just think. Now talk about the carbon and oxygen. See here, carbon is having 4 valence electron in its outermost orbit, oxygen is having 6. So now you talk about the carbon will get 8 electrons, and now you talk about the oxygen will also get 8 electrons. So here you can see here that all the 4 electrons or outer electrons of carbon share with the 2 electrons of both the oxygen, and each and every element will gain their nearest inert gas configuration of neon. So all the elements will have 8 electrons in its outermost orbit. N2F2, 5 plus 5 plus 7 plus 7, that is 24 electron. Now tell me, how many bonds between the N2 and F2? Have you ever thought about this question? That how this nitrogen and fluorine will form a bond? Just check here. This is the fluorine, this is the nitrogen, this is the nitrogen, this is the fluorine. You know very well, the fluorine has 7 electrons in its outermost orbit and nitrogen have 5 valence electrons. Right? Just suppose here fluorine will complete its octet, fluorine will complete its octet. But what's about both the nitrogen atom? Do nitrogen atom will contain? So this is the wrong bond formation between the N2 and F2. Now talk about again that if we share the 2 electrons of nitrogen, you can see here both the fluorine had got 8 electrons, but nitrogen had got only 7 electrons. But if now we take the 2 electrons between the nitrogen and nitrogen, 2 bond pairs we do, then just think. So now here you can see the fluorine had also got 8 electrons, nitrogen has also got 8 electrons. So both the fluorine and both the nitrogen atom got 8 electrons. So this is the right Lewis dot structure of N2F2. Must remember, each and every element must complete their octet. Talk about the cyanide minus ion. So just check it as all the electrons are represented and tell me which will be the correct formula. Here you can see this carbon and nitrogen. Since they are having one charge, so one more electrons are there. So now carbon and nitrogen, you will see here they are both are getting 6 electrons. But if we take the 3-3 bond pairs between the carbon and nitrogen, if you take 2, then what will happen? You know very well, nitrogen have 5 valence electrons, carbon have 4 valence electrons. So what will be the formula? 7 electrons. Now take the triple bond between the nitrogen and carbon atom. So you will get the final result answer that now the carbon and nitrogen both are getting 8 valence electrons in their outermost orbit, and both the elements complete their octet. So this is the Lewis dot structure of the elements. I hope all of you understand about the concept of Lewis dot structure. Right? Now if I talk about how to count the valence electrons, how you will count the valence electrons, how you will understand how many bond atoms are there, place the remaining valence electrons or fully valency, how you will do these all things. For that, just have a trial and error method. According to that, we will learn definitely that they are having the octet or not. Chapter 3, that is Lewis structure, generalizations and exceptions. Here all the chapters in the topic as I have already informed you about it. Okay, so let's start it. That each and every element has a tendency to gain the nearest inert gas configuration. If I talk about the hydrogen will have one bond for hydrogen. Either you take with carbon, nitrogen, oxygen or fluorine. Okay, and these 4 elements will have octet if they just combine with hydrogen. Beryllium and boron. Talk about the octet rules, each and every element less than 8. If they are having less than 8, means 8 minus the valence electron. Octet rule or more. Remember these formulas as I am writing all these. You can see your one bond for hydrogen, octet rule for carbon, hydrogen, oxygen, fluorine, less than octet and more than the octet rule. So the generalizations and exceptions we are going to discuss today. Now just suppose these elements. Beryllium chloride. Let us take a compound beryllium chloride. Beryllium can lose 2 electrons and chlorine can gain 1 electrons. Both the chlorine will gain 1 electrons. So beryllium will get the helium configuration and chlorine will get argon configuration. Let's talk about the electronegativity difference. It is 1.5. So can you tell me which type of bond will be there? Polar, non-polar, covalent bond. First of all, remember it is a covalent bond. Count the total number of electrons. Chlorine is having 7 valence electrons in its outermost orbit. Beryllium having 2. So total number of valence electrons will be 16. But no. Here you can see the 1 electrons has been shared by both the chlorine to the beryllium. So now tell you how many valence electrons. So beryllium is having 4 electrons but chlorines are having 8 electrons. Now tell me, either beryllium, just suppose either not only beryllium, do beryllium complete its octet or do it? No. So this is the exception. BeCl2 is an exception. Let's talk about BeCl3. The electronegativity difference is 1. You know very well, chlorine 3 and talking about the boron, that's 2. So the difference between these two is 1. Now just take the total number of valence electrons, that is 24 electrons. So now talk about the BeCl3. All the 3 atoms of boron are combined with the chlorine. So all the chlorines are getting the octet. But what's about the boron? Do boron get octet? No. Why? The borons are having 3 valence electrons. And 3 2s are 6 electrons boron will get. Right? But chlorine will get the octet completions. Here boron will not get. Now there is a lack of, but just suppose the aluminium, AlCl3. Now here the same, the aluminum is having 3 valence electrons and all the 3 valence electrons are combined with the chlorine. So chlorine will complete its octet. What's about the aluminium? Since the aluminium will lose 1 electron, it will gain an ionic compound. So remember dear students, if you just directly take the formula and calculate the valence electron, that will be wrong. Since we are representing the Lewis dot structure, according to the Lewis dot structure, you must remember that the general elements, how do they complete their octet, and more than octet or less than octet we have to remember. All the fluorines atoms are fully valence, they are having 88 electrons. Talk about the phosphorus. Phosphorus is having 5 valence electron, so phosphorus will also complete. So here 5 plus 7 5 is 35, 35 plus 5, that is 40 electron is wrong answer. Only 30 electrons are. How? That all the 5 electrons are being shared. And you can see here 7 5 is 35, 35 plus 5 electrons of phosphorus, that is 40. So total number of valence electron is 40. Right? PF3, you can see here all the phosphorus contain 8 electrons. If I talk about the sulfur dichloride, SCl2, what you will tell? Sulfur is having 6 valence electron in its outermost orbit, chlorine 7 that's 20, but the 20 valence electron is wrong. You know very well that both the electrons of sulfur are being combined with the chlorine. Chlorine complete its octet, so 8 electrons of chlorine and 8 electrons of sulfur, right? 8 plus 8 plus 8, that is 24. Talk about SCl6. Sulfur is having 6, chlorine is having 7. So 7 6 is 42 plus 6 48 electrons. So is this right? 48 electron, is it right? Just I am asking to you. Now just suppose here the sulfur is having 6 valence electron. All the chlorine atoms will contain 88 electrons. So 8 6 is 48. 48 plus 12. How many? See, all the chlorine atoms will get their octet completion. SCl2, yeah, sulfur will have the 8 electrons, chlorines are also having 8 electrons. So SCl2 is right. SCl6 12 electrons they will have. So remember these things, that how to write the Lewis dot structure of these whole elements. I hope all of you have enjoyed this video, and after then we will discuss more about in the next video. That's all for today. Hope all of you have enjoyed. Don't forget to like and subscribe the channel. That's all for today. Thank you very much.